Hey guys, I'm off visiting with my wife. I'm spending the entire day with her. It's her birthday. I want to remind you to make sure that you grab your ornaments. And also, if you brought a Tupperware container or a plate and you haven't brought it home, take it now. I don't want to see any of these things when I come in tomorrow. And if you don't take them now, I may have to throw them away. So please grab them now so that no terrible circumstances happen to them, and I'll see you tomorrow. You guys have a great day. Okay, today we're going to be graphing inverse trigonometric functions. And I know you guys are still grappling with what we've been doing, but it's just, again, a way to take the sine and cosine ones and manipulate them in different ways. And we'll be doing this more and more. So even if you don't get it today, there's going to be time to move on. So let me remind you, first of all, what an inverse trig function is. We can write them this way: sine inverse, cosine inverse, tangent inverse. They do not mean reciprocal. It's not to the negative 1 power. Because remember, we have other words for that. We have secant, cosecant, cotangent. Those are reciprocals. Those are different than these. They are not the same. The inverse means, and we'll get to the practical application in a moment, is that the y becomes the x and the x becomes the y. In other words, when I find the sine of theta, I'm finding the opposite value of the triangle and over the hypotenuse. When I'm trying to find the sine inverse, I'm not trying to find the sine inverse of an angle. I'm trying to find a sine inverse of some ratio given by opposite over adjacent. So it works the backwards way. Here I take the sine of an angle. It gives me the ratio of two sides. To take the sine inverse, I take the sine inverse of a ratio, and it tells me the angle. It works the other direction. I know I've said that like 1,000 times, but hopefully, maybe this time it'll actually make sense. Another way that this can be written is we write arc sine, because sine inverse sometimes can seem like it's a reciprocal power, which is not what it is. This is not cosecant. So that's why they have two terms. This is shorthand, and this is probably the older, more official term. And so you'll see both used synonymously in the book. So first, before I graph this, because we're going to be graphing these, before I graph arc sine or sine inverse, I'm going to just remember how sine is graphed. Remember, sine starts in the middle, its period is 2 pi, and it follows the pattern up, middle, down, middle, both directions, following this up and down pattern, and goes like this. Now, the sine inverse is going to swap out the y values for the x values. We'll graph that in just a moment, but before we do, we need to understand that because this is continually repeating itself, the sine inverse on your calculator and how we define it is actually contained within only two quadrants. It's true for sine inverse, cosine inverse, and tangent are only contained in 2 quadrants, so the graph itself is limited. It's boxed in, and it's only one portion of the whole. So if you look at the unit circle here, here's first quadrant, second quadrant, third, fourth. Your calculator, and this is how we define it, when you type in sine inverse, it will only give you an answer either in the first quadrant, so 0 to 90 degrees, or in the fourth quadrant. And how it'll type it is 0 to negative 90 degrees. It won't say 285 degrees going this way. It would say negative 75 degrees. That's what it would say. And so when you type in sine inverse, tangent inverse, they'll give you quadrant 1, quadrant 4 answers in your calculator. That's how it's defined. It's not anywhere else. It's not going to give you an answer over here. So sometimes you have to figure out what's going on over there if that's needed. Your calculator is only going to tell you one side. Cosine is the one that's different. It's first quadrant and second quadrant, because cosine's positive here, negative there. Sine is positive here, negative here. Tangent is positive here, negative here. It's also negative here, but they just chose, well, let's go this way with tangent. It could have gone the other way. They chose that way. Okay? So, the big idea is I'm going to graph this graph. I'm going to switch y's and x values. I'm going to make the x value a y value, the y value an x value. But I'm only going to graph it in these two quadrants. And if I use the idea of this is negative 90 degrees and this is positive 90 degrees, or in other words, in radians, this is pi over 2, and this would be negative pi over 2. So that means that my new x coordinates, or sorry, my new y coordinates, because these were formerly x coordinates, right? Negative pi over 2, pi over 2. These are my left and right boundaries. They're now going to become my bottom and top boundaries. What was left and right becomes bottom and top. What was bottom and top becomes left and right. So the bottom is negative pi over 2. The top is pi over 2. The bottom boundary was negative 1. The top was 1. So the left is negative 1. And the right is 1. Those are my boundaries here. And my graph's going to be only in this section. And so now I'm going to look here. Well, here I have the point 0, 0. So if I switch 0, 0, it's still 0, 0. Here I have the point pi over 2, 1. Pi over 2, 1. So now I'm going to have the point 1, pi over 2. Switched. Here I have the point negative 1, negative pi over 2. So instead I'm going to have, it's not negative, it's negative pi over 2, negative 1. So now I'm going to have negative 1, negative pi over 2. And these will look like they're in a line, but just like these look like they're in a line, but they're not, it's on a curve, I need to look at this section and how it would look if I had switched the x and the y's. And the simplest way for me to say this is, think of it going vertically on the two ends and then curving in. Because remember, these two ends represent the peaks, where it kind of flattens out. And these flatten out horizontally, so this would flatten out vertically. Okay, so that's the idea. You can do this to cosine, to tangent. You just graph the one section and you switch all x and y values. Okay, now I'm going to do just some really quick evaluation of some arc, cosine, sine inverse, cosine inverse expressions using the unit circle. So once again, I'd remind you that as on that chart, sine inverse and tangent inverse, I'm going to look only at quadrants 1 and 4 on my unit circle. So that's the right side. I'm not going to look at the left side, only the right side. Cosine inverse is quadrants 1 and 2. So for cosine inverse, I'm only going to look at the top half, not the bottom half. Just the top half. So real quickly, here's how it goes. The arc sine of negative 1. So I look, where is sine negative 1 in these two quadrants? I have to look in these two quadrants, and you'll see sine's the y coordinate at the very bottom, and at 3 pi over 2, on your unit circle, it says that arc sine is negative 1. But 3 pi over 2 is going this way, and technically we go the other direction for arc sine. Remember, we have negative 90, or negative pi over 2. So if you wrote 3 pi over 2, I would accept that, but I would prefer negative pi over 2. This is what your calculator would give you. As a decimal, it wouldn't actually write it this way. And that's it. That's the whole problem. Look at the right place, write the answer it tells you to. So for a super complicated one like this, I go, okay, sine inverse of 1/2. Where is sine 1/2 in these quadrants? And I'll find, if I look for the y coordinate, where sine is 1/2, I should get pi over 6. Pi over 6. Minus the cosine inverse of 1, so I'm looking where is the cosine 1, and that's at 0, so minus 0. So this became pi over 6, minus this at 0. And now I'm going to take the cotangent of this, the cotangent of pi over 6. And if you look on your sheet, cotangent is the x over the y. And at this place, the x coordinate is the square root of 3 over 2 divided by the y coordinate, which is 1/2. Remember, this divided by this, they're divided by the same denominator, so they both cancel. So it's the square root of 3 divided by 1. which is just the square root of 3.